Welcome to the session of velocity of sound. The aim of the experiment is the apparatus we are going to use for this experiment is resonance apparatus, tuning forks and rubber hammer.
Now, let us describe the resonance apparatus. The apparatus consists of metal tube arranged on a wooden board. There is a transparent side tube which is connected to the bottom of the metal tube. This transparent tube is placed on the meter scale. The zero of the meter scale coincides with the upper end of this tube. The water in transparent tube and the metal tube is at same level. Hence, the reading of the water level is taken in the transparent tube. The bottom of the metal tube and the transparent tube is connected to the reservoirs by means of a hard rubber tube.
The formula we are using in this experiment is Vt is equal to 2n into L2 minus L1. Here Vt is the velocity of sound at T degree centigrade, that is at room temperature. N is the frequency of the vibrating tuning fork. L1 is the first resonating length of the air column and L2 is the second resonating length of the air column. Let us discuss how to determine the velocity of sound at room temperature. As L1 and L2 are the first resonating length and the second resonating lengths, we have to first consider the frequency of the given tuning fork, that is, consider 512 Hertz. Take the rubber hammer and now if you beat the prongs of the tuning forks with the rubber hammer, it will be under vibration mode. Now we have to adjust the length of the air column by moving the reservoir slowly in the downward direction. After that, we have to keep the vibrating tuning fork above this air column in the given metal tube without touching the metal tube. After we determine the first resonating length, we have to move the reservoir in the downward direction, and again we have to beat these prongs of the tuning fork above the air column till we get a large booming sound that will give you the second resonating length. In this way, L1 and L2 should be determined. To determine the first resonating length in trail 1 position, we have to consider the tuning fork and the rubber hammer. Vibrate the tuning fork by beating it with rubber hammer and place it on the open tube. Now adjust the reservoir. After adjusting it, fix the reservoir and again beat the tuning fork. That is the booming sound we have to recognize. Observe the air column here in the rubber tube. It is 16.5 centimeters. Now for trail 2, adjust the reservoir there at 16.5 centimeter to 16.6, fix it, and again we got the resonating length in trial 2 at 16.6 centimeters. After getting the two values in trial 1 and trial 2 as 16.5 centimeter and 16.6 centimeter, the average of these two will give you L1, the first resonating length for 512 Hertz frequency. Now we have to determine the second resonating length. For that, in the trial 1, we are going to decrease the reservoir in the downward direction up to nearly 49 centimeters, and the 512 Hertz frequency tuning fork at the open end it is at 49.8 centimeter. Now repeat the same experiment for 2 or 3 millimeters difference according to our convenience till the large booming sound is going to come. Like this. After getting the booming sound, it is at 49.5 centimeter. So we have trial 2 reading 49.5 and trial 1 49.8. The average of these two values will give you the second resonating length, that is L2. When we know the values of L1 and L2, as we said the formula earlier, the velocity of sound at room temperature Vt will be equal to 2 into n into L2 minus L1. Here n is 512 Hertz, L2 the average of the two values in the second resonating length, and L1 is the average of the two values in the first resonating length. We get the velocity of sound at room temperature. In this way, we conclude the experiment velocity of sound.